Alright, so in this video I'm going to talk to you about natural numbers and some related topics like positional notation and the definition of digits, what arithmetic is the study of. Alright, so let's get started. So what are natural numbers? Well, there's lots of different types of numbers that we will learn about. Right now we're going to focus on what's called natural numbers. These are numbers like 0, 1, 2, 3, 4, 5, 6, etc., etc. Okay? And these are the numbers that we use to when we're counting something. That's why natural numbers are also called counting numbers. Another name for them is whole numbers. All right? So we have natural numbers, counting numbers, and whole numbers. Let me write all those down. Natural numbers, counting numbers, and whole numbers. Those all mean the same thing. Now, with one little comment. The definition sometimes includes 0 and sometimes it does not. So I just want to bring that to your attention that you might talk to somebody and they'll say, okay, the counting numbers or the whole numbers, of course they start at 1 and then they go 2, 3, 4, 5, and they don't count 0. Okay? But a lot of people do count 0, and I will be using that definition, the definition of these types of numbers as including 0. All right? So these, what I've written here, these symbols, 0, 1, 2, 3, 4, 5, 6, etc., those symbols represent quantities, a certain number of paper clips, a certain number of cell phones, sheep, mountains, people, okay? Quantity, in fact, if you want to know what arithmetic is, think of it as the study of quantity. Okay, that's arithmetic. That's what we'll be doing a lot of in pre-algebra. Okay, now what would a study of quantity look like? Well, what happens if you have 3 sheep and you double the amount of sheep? What new quantity do you have now? Or what if you have 6 candies and you eat 2 of them? How many do you have then? Okay, these are some questions that a science of quantity, in other words, arithmetic, could help you answer. All right? So now that we know what arithmetic and natural numbers are, and we know you've seen some symbols to represent natural numbers, let me tell you what happens if we want to represent a really big quantity. All right? Let me add a few more symbols to my list here. So you could have also 7, 8, and 9. All right, now I've written down 10 symbols with commas in between. All right, it turns out that we're going to be able to represent a lot more than 10 quantities with just these 10 symbols. Okay, let me show you how we do that. What we do is when we have more than one of these symbols, and by the way, these 10 symbols are referred to as digits. The reason they're called digits, another word for a digit is, or another meaning is your fingers. All right, people used to count with their fingers. There's 10 fingers, so it was natural to associate numbers with fingers, and so the word digit means both the symbol here and your finger. Okay. All right, so what if we wanted to represent a number bigger than 9? That's the last one there on the right. Do we have to make up a new symbol? All right, what I'm going to do is I'm going to write the symbol 1 and a 0. All right, this is called positional notation, and what this means is that you have 0 of a regular quantity. All right. However, you have 1 of a special quantity. That 1 represents you have one group of 10. All right. One package of 10 iPhones or staplers, whatever quantity, whatever object it is you're measuring. All right, so this is how you would represent the number, the quantity after the number 9 without using a new symbol, just recycling the ones you have left. All right, and we could keep going. We could do something like this. This is the number 234. All right, so you can think of this as this represents, the 3 represents a package of 10. All right, so that means if you have represents 3 packages of 10. So that represents 30 objects. And then the 2, if you have 3 numbers, the first one represents packages of 100. So you have 2 of those, so that means you have 200. So to figure out what that number is, you have 200 quantity, 200 or 2 groups of 100, 3 groups of 10, and then 4 additional objects. All right, and that makes 234, as they say. Okay, let me give you the names of the columns now. So the first column is referred to as the ones column, because that tells you how many groups of 1 that you have. The next position is referred to as the tens, because as you saw, it tells you how many groups of 10 you have. And then the next one, you can probably guess what I'm going to say. It's the hundreds column, hundreds position, hundreds slot, whatever word you want to use. And then we could keep going. If I had 4 digits, like let's say I had, instead of 234, what if I had 1,234? Well, then this is that would mean you have 1 package of 1,000 objects. Okay, that's the thousands column. And then we could keep going in bigger and bigger quantities, bigger and bigger packages by adding more digits. After that would come the 10,000s, 100,000s, millions, etc., etc. Okay? So that is a brief introduction to natural numbers and digits and arithmetic. Now, let me give you some examples, and let's see if you can answer the questions I'm going to give you now. Alright, so I'm going to put some numbers here on the screen. So this is the number, the first one I put, there's 234,567,890. And let me put one more. All right, so the first number, the big one, would you please tell me what number is in the tens column, the tens position, however you want to say it? Okay? What number is in the tens? And go ahead and tell me for each number. What digit, what symbol is in the tens column? All right? For the first number, the answer is 9. Is in the tens column. For the second number, the answer is 1. All right? Now, for the first and second number, what digit is in the 10,000ths position? See if you can answer that. All right, so for the first number, the 10,000th position is has a 6. All right, I'll put a little arrow to the 6 right there. That's the 10,000ths position. And then on the bottom one, the 4, which I'll put an arrow right there, is in the 10. That's the 10,000ths position. And for the tens, which I previously had asked and answered, I'll draw an arrow to those. So the 9 and the 1, that's the tens column. All right, so let's end with this last question. What, in the first number, what digit is in the millions column? All right, so the millions, you might know that a million comes after, well, a million has 7 numbers in it. Okay, so if you know that, you might use that to help you remember that it has to be the seventh number starting from the left. So it turns out that the 4 is the millions number. All right, so I hope that was instructive, and that's all I have for right now.